Algebra 2 students, this is the video that's going to walk through your review slides for today, Monday, March 25th, covering all topics that we've discussed in Chapter 6, which is all about fractional exponents and radical functions. So how to combine them, how to simplify them, how to solve equations with them, and how to work with them in different functional notation operations. So let's go ahead and get started. What you want to do is pick different sections that have felt challenging to you. So I would recommend jumping around your packet. So if you already know how to do a specific kind of problem, don't spend your time doing that. Instead, find ones that still feel a little bit tricky to you and spend your time studying those. So I'm going to get started with section 6.6, which is all about solving radical equations. And there are 4 different things you need to know from this section. The first thing that you need to know is how to solve a basic radical equation. That's one where you just have a single expression or a binomial inside of a radical, and you have to undo it with the corresponding exponent. You also want to be able to solve fractional exponent equations. So those are going to be ones where you're flipping the exponent fraction to undo it. You want to solve radical equations that require you to check for extraneous solutions. So anytime you're not just solving things equal to a single number, but equal to an algebraic expression, you want to take your results, go back and plug in. And then last step, how to solve radical equations that involve foiling. So that means the expression setup is ultimately going to cause you to FOIL. The foiling is going to involve radical multiplication. So 4 kinds of problems from this section. First one, example number 1, says solve the following equation, and we have the quartic root of x plus 1 minus 5 is equal to negative 2. So in order to get started with a problem like this, you just want to isolate the radical first. So in this case, that means getting rid of this minus 5. And that's going to give me that the quartic root of x plus 1 is equal to positive 3. Then in order to undo that quartic root, what I need to do is raise both sides of the equation to that value. So I'm going to raise both sides to the 4th power. That will eliminate the radical, so I'll be left with x plus 1 equals 3 to the 4th. This should be on your perfect powers page, but if not, you can certainly use your calculator here to find that 3 to the 4th is equal to 81. Then I can subtract 1 over, so I can subtract 1 here, and 81 minus 1 is going to give me a solution of x is equal to 80. And that's my final answer there. I want to take the same approach with example number 2, where my goal is really to start off isolating the expression that has the radical or the fractional exponent. So here I need to add over 3. And when I do that, I will have 2x to the 2/3 power is equal to 50. Now I need to divide both sides by 2 because I need that exponent fully isolated with the x with nothing else on the same side. 50 divided by 2 is going to give me 25 on the right. Now that the fractional exponent is fully by itself, I can get rid of it by raising it to the reciprocal power. So in this case, to the 3/2 power. Those values will cancel because the 3 here's cancel, the 2's here cancel, and we're simply left with x. So x is equal to 25 to the 3/2 power. And again, with these kinds of operations, if they end in a decimal, we want to leave them in exact form. However, if they can be simplified, that's what we want to do. So here, if you take 25 and raise it to the 3/2 power, remember that when you input this into your calculator, you want your input to look like this. Your little caret, and then you want the fraction in parentheses so that you get the order of operations correct. So when I do this in my calculator, I get a result of 125. We could also see that by noting that 25 to the 1/2 power would be 5. 5 cubed would get you to 125. So that's our final answer for that fractional exponent problem. Now let's try example number 3. Example 3 and 4 are going to be a little bit more involved than examples 1 and 2. There's just a little bit more math work involved. So here, the first thing on example number 3 that I want to do is isolate the radical, just like in example number 1. So I'm going to add a 1 over here, and I'm going to add a 1 over here. So I will have the square root of 19 minus 3x is equal to 3x plus 1. Then what I need to do is to get rid of the radical. And the way I'm going to do that is by squaring both sides. That will undo the radical. But what I need to remember is that this 3x plus 1 squared is really the same thing as 3x plus 1 times 3x plus 1. So I cannot distribute that exponent. I need to FOIL out the expression. So when I do that, first I'll multiply 3x and 3x, which will give me 9x squared. Then my inner term will give me a 1 times 3x, as will my outer term. So when I combine those together, I'll get plus 6x. And then my last expression, when I multiply 1 and 1, will still give me 1. At that point, I need to combine like terms. So what I'm going to do is add the 3x over here and subtract the 19. So that way I'm combining all like terms on one side. So I'm going to add 3x, subtract 19. So what that will give me is that 0 is equal to 9x squared plus 9x minus 18. Good news is that all of those terms are divisible by 9. So I can bring a 9 out in front and I'll be left with x squared plus x minus 2, which looks like a factorable expression because I want to figure out what multiplies to negative 2 and adds to 1. And that is going to be positive 2 and negative 1. So if I set these equal to 0, I'll end up with negative 2 and positive 1. Unfortunately, we are not quite done at that point because what we need to do is plug both expressions back in. So we need to plug the negative 2 and the 1 back into our original equation. So grab your calculator and start off by plugging in the negative 2 operation. So if you take 19 minus 3 times negative 2, and you take the square root of that and subtract 1, that is a different result than what you get if you plug negative 2 on the right-hand side. So our final answer here is just going to be the positive 1 result. That's the only one that checks out. If we plug that in, we will end up with 3 on the left-hand side and 3 on the right-hand side. So this is our extraneous solution. Then we have example number 4. It's going to be a similar process, so we're going to have some foiling to do, but it just so happens that the foiling over here is going to involve a radical. So again, the only way to undo a radical, a square root, is to square it. So I'm going to square this side, and I'm going to square this side. On the left-hand side, that's just going to leave me with what's inside the square root. But this operation, what I have to do is multiply 5 minus the square root of x times 5 minus the square root of x. So my first term there will become a 25, and then I will have a minus 5 root x, and then another minus 5 root x. So that's going to become a minus 10 root x. And then I'll have a negative root x times a negative root x, which is just going to become positive x, because anything under a square root times itself is just going to leave you with that value that was originally under the root. So now I can combine like terms. The good news here, kind of what makes this an easier problem, is that with this one, the x's happen to cancel out right away. So I have 3 equals 25 minus 10 root x. So then what I want to do is subtract 25 from both sides. 3 minus 25 is going to give me negative 22, which is equal to negative 10 times the square root of x. And then what I want to do there is divide both sides by negative 10, divide by negative 10, and that's going to give me positive 2.2 equals the square root of x. So my last step to get x by itself is going to be to square both sides. So I'll have x is equal to, if I take that 2.2 and square it, you need your calculator for that, but you get 4.84. Now just to be on the safe side, you always want to plug these back in and just make sure that it checks out. So on the right-hand side, when I plug in, I get 2.8. And on the left-hand side, when I plug in, I also get 2.8. So that solution checks out. So that's our section 6.6 content. Section 6.5 is all about graphing square and cubic roots. So we want to be able to graph square root functions and cubic root functions, both by plotting points and by using our graphing calculator. And then we want to be able to figure out the domain and range for those functions. So the first square root function that we have is 3 times the square root of x. And if you're just trying to graph something, what I want you to do is a two-part process. First, I want you to pick some points to plug in, and then I want you to use your calculator to confirm that you have the correct shape. So when I look at this function, what I have inside of the square root is the x plus 2. So that operation is going to have to be bigger than or equal to 0. Otherwise, I'm going to get imaginary numbers. So what that means, if I subtract over the 2, is that my x values can start at -2 and then they can get as big as I'd like from there. So to plug in, let's do -2. Let's also do 2, and then let's do 7. And we'll have a pretty good shape of the graph from there. So if I plug -2 into this operation, the square root will become 0. Multiply that by 3, I'm still going to get a 0 out. So that point will be -2, 0. I can plug a point right there. If I plug 2 into the operation, I'll have 2 plus 2, which is 4. The square root of 4 is 2, and then 2 times 3 will give me a 6 out here. So I'll have over 2 up 6 is going to put me here. And then 7, if I plug 7 in, I'll get 7 plus 2, which is 9. Square root of 9 is 3, times 3 is 9. So I'll go over 7 and up 9 here. So my graph shape is going to look like this. Now, if you go back in your notes, the parent function for the square root graph, you can re-sketch those points out here, but you'll see that the points that we plotted before are going to give us this graph, so this shape. So there are a couple of things that changed from the parent function graph to the graph that we have here. What we have that's different is that there's a vertical stretch, and that comes from the 3 out in front. So we can say by a factor of 3. So the values that we plug in are going to be amplified, meaning the graph is going to get bigger faster. And then we also have a horizontal shift to the left. And that comes from the plus 2 inside. The last thing this problem asks us to do is to identify the domain and range. So along the way here, we actually already identified the domain. The domain is that your x values start at -2 and then get bigger from there. So my domain is that x needs to be greater than or equal to -2. And you can think about that graphically, because this is where your x values begin, is at x equals -2. Or you can think about that algebraically, because in order for this square root to be 0 or larger, this x value needs to be -2. Then we can also write down our range. So our range is where our y values begin. And again, you can think about that graphically, or you can think about that from the equation. If you think about it graphically, notice that your y values start at 0. If you think about it from the equation, if the smallest x value you can plug in is -2, that means the biggest number you can get from the square root is a 0. So my y values have to start out at 0. So my range is that y is greater than or equal to 0. So I'm going to go ahead and stop this video, and then I'll pick up on example number 2 for section 6.5.